Hello students, welcome to Saurav Sir's classes. The question is, in the context of the linear model, y is equal to x beta plus epsilon, consider the following statements. If x is a full rank matrix, then all the linear parametric functions are estimable. And statement 2, each estimable linear parametric function is of the form c dash x beta for some vector c. Which of the above statements is correct? Option A 1 only, option B 2 only, option C both 1 and 2, and option D neither 1 neither 2. Now let us analyze the statements one by one. Statement 1 is, now analyzing statement 1. X is a full rank matrix, then all linear parametric functions are estimable. Well, this is true because since X is full rank matrix, you have information about all the data that is given to you and nothing can be truncated from here, that is, there is no loss of information, and thus all the linear parametric functions are estimable. And statement 2, each linear parametric function is of the form c dash x beta for some vector c. This is false. It is of the form c dash beta and not c dash x beta. So option A is the correct answer. The next question is, for a two-way ANOVA with 6 rows, 4 columns and 3 observations per cell, the degrees of freedom for interaction and residual are respectively. Here we have been given that number of rows is equal to A is 6 and the number of columns is B is equal to 4. We have also been given that number of observations per cell, which is basically the number of replicates, to be R is equal to 3. Thus, the degrees of freedom would be degrees of freedom for interaction is equal to A minus 1 into B minus 1. This comes out to be 6 minus 1 into 4 minus 1. This is actually 5 into 3 is equal to 15. And degrees of freedom for residuals comes out to be is actually AB into R minus 1. Thus 6 into 4 into 3 minus 1, 6 into 4 into 2, this comes out to be 48. Thus the correct option is option B, that is 15 and 48 respectively. The next question is, as the variability due to chance in an analysis of variance decreases, the F statistic in the ANOVA, option A will always increase, option B will always decrease, option C will remain constant, and option D requires additional information to claim any change. Well, so let SSA be the sum of squares due to the factor A, and SSE be the error of sum of squares, which is the variability due to chance. Now we know that TSS, that is the total sum of squares, is equal to SSA plus SSE. Now, in ANOVA, the F statistic is given by SSA by degrees of freedom for SSA whole divided by SSE by degrees of freedom for SSE, which is the mean sum of squares due to factor A by mean sum of squares due to error. Now, since TSS is constant, if SSE increases, it implies that SSA decreases. Now this implies that MSE increases since SSE increases, and thus MSA decreases. So this will give, so thus if we use this in the F statistic, we see that the F statistic will always decrease. So option B is the correct answer.